So if you've logged into pretty much any website or app today, you've used something called a JSON Web Token, or JWT for short. Think of them as the universal passport of the internet. They're the invisible credential that lets you navigate around without having to type in your password over and over again. They basically run the modern web. But here's the thing. Even though they're everywhere, they are probably one of the most misunderstood pieces of tech in a developer's toolkit, which leads to a pretty direct question. You use these things all day, every day, but do you actually know the ridiculously simple ways they can be cracked wide open? And that really is the heart of the problem we're going to dig into. Nearly every app you build or use is built on JWTs, but a huge number of developers just don't fully get the security risks involved. And this isn't some, abstract academic problem. It's a ticking time bomb in countless applications that are live right now. All right, so let's get into it. To understand how to break a JWT, we first have to understand what it is. And honestly, the best way to think about it is like a digital passport, one that's made up of three very distinct parts. Okay, so when you first see a JWT, it just looks like a total jumble of random letters and numbers. But it is anything but random. It's actually a very structured string, and you can see it's made of three parts, separated by those two little dots. Each color here represents a different section of our digital passport. And this is where that passport analogy really starts to make sense. The first part, the header, that's like the cover of the passport. It says what type of token it is, and this is super important, the signing algorithm that's being used. The second part, the payload, is like the main info page. This is where you find the claims, stuff like your user ID, your permissions, maybe an expiration date. And then that final part, the signature, that's the official tamper-proof seal. It's the cryptographic proof that says the header and payload are legit and haven't been messed with. And right here, this is the first huge gotcha that trips up so many developers. The header and the payload, they are not encrypted. They are just Base64 encoded. You see this long, opaque string, and it gives you a false sense of security. But let me say it again, Base64 is not encryption. It gives you zero security. It's just a way to make sure data can be sent as text, and literally anyone can decode it in a second. You've got to understand the difference here. Encoding, like Base64, is like translating a sentence into another language. Anyone who knows that language can just translate it right back. Encryption, on the other hand, is like locking that sentence in a safe. You absolutely cannot get it back unless you have the secret key. A JWT's payload is just translated, it's not locked away. So you might be thinking, well, if anyone can read the data, where's the security? And it all comes down to that third part, the signature. That signature enables this incredibly efficient process called stateless authentication. And this is the real magic of JWTs. It's why they're so popular. Let's just walk through how it's supposed to work. You log in with your username and password, the server checks them out, and if they're good, it creates a JWT and signs it with a secret key that only the server knows. Then it sends that token back to you, the client. From then on, your browser just includes that token with every single request you make. The server doesn't have to look you up in a database every time anymore. It just looks at the token, verifies the signature is valid, and if it is, it trusts everything inside and gives you access. It's super efficient. But, and this is a big but, this really elegant system relies completely on the integrity of that signature. And if it's implemented wrong, it has some massive flaws. So now we get to the fun part, the reveal. Let's look at 3 ways this whole system can be completely and utterly defeated. Okay, our first attack is so simple, it's almost insulting. It's called the none algorithm attack, and it basically just tricks the server into not even checking for a signature in the first place. Just look at this. All an attacker has to do is grab a token, decode the header, and change that one little value, the alg value, from something like HS256 to none. That's it. That's the whole hack. So why on earth does this work? Well, after changing the header to alg none, the attacker just chops off the signature part of the token entirely. Then they send this fake 2-part token to the server. Now, if the server is badly configured, its JWT library will see alg none and just think, oh, okay, no signature to check here. And it accepts the payload as completely valid without any verification at all. At that point, the attacker can put whatever they want in the payload, like admin, true, and the server just believes it. Game over. All right, this next one is way more clever. It's called algorithm confusion, and it plays on a fundamental misunderstanding between two totally different kinds of signing algorithms.
So what you're seeing here is the switch. The attacker takes a token that was originally signed with an algorithm called RS-256, and they just change the header to say it was signed with HS-256. These two work in completely different ways, and that's the whole key to this exploit.
Okay, let me break this down because it's wild. RS-256 is asymmetric. That means it uses a secret private key to sign the token, but a totally separate publicly available key to verify it. HS-256, on the other hand, is symmetric. It uses the exact same secret key for both signing and verifying. So what the attacker does is change the algorithm to HS-256. Then they grab the server's public key, which is often easy to find, and they use that public key as the secret to sign their fake token. Now, when the server gets this token, it looks at the header and thinks, okay, it says HS-256, so I need to use my shared secret to verify this. But what secret does it grab? It grabs the public key it has on file. So the attacker signed with the public key, and the server just verified with the public key. The signatures match, and the fake token gets a green light. Now, this third vulnerability isn't really an active hack in the same way. It's more of a fundamental property of JWTs that is just dangerously ignored all the time. And that is the simple fact that the token's payload is basically an open secret. We've already touched on this, but seriously, it cannot be said enough. Anyone who gets their hands on a JWT can instantly read everything in the payload. That could be someone on the same coffee shop Wi-Fi, a network admin, or a hacker in the middle of your connection. So if you're putting truly sensitive information, I'm talking social security numbers, personal health info, credit card details, inside a standard JWT payload, you are practically broadcasting it for the world to see.
Okay, so that was a lot of bad news. But here's the good news. Every single one of these vulnerabilities is 100% preventable if you configure your server correctly. So, let's switch gears and talk about fortifying the vault. Let's build your JWT security checklist.
Here are the absolute non-negotiables. 1, obviously, always validate the signature. 2, and this is the big one, your server should have a whitelist of one and only one allowed algorithm. Never, ever, ever trust the alg value coming from the token itself. That one step alone defeats both the none attack and the algorithm confusion attack. 3, use a long, strong, hard-to-guess secret key. 4, keep your token expiration times as short as you practically can. And finally, one last time, do not store sensitive data in the payload. Now for one last, super critical piece of advice that is directly for you, the developer. When you're debugging, you often need to see what's inside a JWT. And the first thing so many people do is just copy it and paste it into some convenient online decoder. Please take this as a very serious warning against ever doing that. And here's why. When you paste that token into an online tool, your token leaves your machine. You have no idea what's happening on their servers. Are they logging it? Could they have a data breach? If that token is still active, you've just handed over a live key to your entire application. The only safe way to inspect a JWT is with a local client-side tool that does everything right there in your browser. Your data should never leave your machine. Here's a pro tip. Open your browser's network tab. If you see a network request fire off when you hit decode, you know your data is being sent somewhere else. And that really brings us to our final thought. The none algorithm attack works because a server blindly trusts the header. The algorithm confusion attack works because a server trusts the header. Leaking tokens in online tools happens because a developer trusts some random third-party service. The absolute foundation of real security is to trust nothing and verify everything. So the question I want to leave you with is this. When you look at your own apps, is their security built on flimsy trust, or is it built on solid verification?